This video is meant to be a short, basic overview of using some basic math functions in Excel, and then how we can apply these to our lab this week, where we are calculating RNA concentration as well as doing some math to figure out the volume of our samples that need to be loaded into our RNA gels. So we'll start here with a basic subtraction formula. So in Excel, you can do this by clicking on the cell you wish your answer to show up in, just like here. So you click on that, and then you click on your values. So here we're going to subtract B from A. So we type in equals, click on the cell that represents our value for A, and then simply tap minus, and then click on our cell that represents value B. And then Excel will calculate this for us and give our value. Our next basic math function is very similar. So here we are going to add the values for A and B. So we just simply type or click on the cell we want our value to show up in, click equals, click A plus B, just like this, and then hit return. And we put our formula in, and now Excel has added our values A and B together. Now, where things start to get a little more exciting in terms of the things you can really do with Excel, let's try multiplying A and B. So very similar to adding and subtracting. We click on our cell where we want to plug our formula in. We type equals. We click on the cell that represents our value A. Do Shift 8 for the star symbol, which represents multiplication. And then we simply click on the cell that represents our value B. And then voila, our Excel sheet has now multiplied for us. And very similarly, you can do this with division by simply repeating the process and clicking the divide button as opposed to the multiplication button. So when using Excel to multiply or divide or add values that represent units, we have to remember to basically take this into account when we're setting up our formulas. So we can't actually type in this example, 17 milligrams in the cell we want to represent our value for A. If we type in numbers and letters, Excel gets angry and it won't do our math functions for us. So we need to set up this information in different cells and make sure it is accurate so that when our values get reported, like here, we know the final unit. This portion is specific to our lab this week. So up here on the screen, we have a table that is very similar to the table you guys will find in your protocol. And this is a table we're going to be using to calculate volumes of samples and volumes of additives to our samples when we run our samples through our RNA gel. So the first thing we need to do is figure out the volume of our sample we need to add to our RNA tubes by dividing our total mass of RNA. So here in the column, 1 microgram. So here, when we divide micrograms by micrograms per microliter, unit-wise, we are left with microliter. And we can see that that's the value or the unit expressed in the column we are working with. Next, in our volume of 6x loading die column, we're going to plug in 3.5, because for each RNA tube sample that we're going to prep, each of these is going to receive 3.5 microliters of loading dye. So this is a fixed value that is identical for each sample. And the last thing that we have to add here now is the volume of RNase-free H2O we're going to add to our sample to bring the total volume up to 20 microliters. So if you look all the way to the right, our total volume for each sample has to equal 20 microliters. And now we basically just have to calculate how much RNase-free water has to be added. And using Excel, this is very easy. Right? We can click on our values for volume RNase-free, click equals, and then start our basic subtraction function, right? So we are going to click on 20, because that's our total volume, minus our volume for the 6x loading die, and then subtract the total volume of our RNA sample that we're placing in, right? So this becomes 20 minus 3.5 minus the volume from our previous calculation for volume of RNA sample. And once this is done, then we can use our little cheat function here in Excel, so we can highlight our two cells with formulas in them, click the bottom right of our of these boxes or the selected range, and then drag down, and Excel will automatically transport our formulas down into the cells below. And then to clean this up a bit, we are going to remove some of these sig figs. You can't see this, but up in the top right, there's an arrow button with zeros, and you can just click that to reduce the number of sig figs reported. So in the unfortunate circumstance that our RNA samples are too dilute, we will end up having to use our max volume for the RNA samples. In this case, 16.5 microliters. So if we do this, we have to normalize other samples to our most dilute RNA sample. This is going to be basically our concentration limiting step. So we can do this by simply multiplying the concentration of our sample by 16.5 to calculate the max mass of RNA we need to load in for each sample. And so now that we've calculated the max mass of RNA for our most dilute sample, we can go through the process to figure out what volume from our other samples we need to include in our RNA tubes so that each of our samples going into RNA tubes all contain the same amount of RNA. And we need to do this so that when we run our gels, the same mass or quantity of RNA has been added to each one, and they run evenly through our gel. So when we make our comparisons, they're direct comparisons and not simply comparisons of samples that have 3 times the amount of RNA as other samples. So to do this, we just approach this similar to what we would for our previous example. We type in 0.495 micrograms of RNA. That's the value we calculated for quantity of RNA we can use from our most dilute sample. And then we just quickly do our math again. So 0.495 divided by the concentration of each sample. This will help Excel spit out the volume we need to use from each sample. So there's a range here, as you can see, all the way from 16.5 microliters, again our most dilute sample, and then 12.375, as well as all the way down to 0.2475 microliters. And now that we have the volume of RNA sample we're going to add to our RNA tubes, we just repeat the function to calculate how much RNase-free water we'll add to our sample. And again, we just do this by typing in equals 20 minus the volume for our loading die and the volume from our RNA samples, right? This has to add up to 20. So real quick Excel math will take care of this for us. And now we have our final volumes for all of our samples for prepping our RNA samples to run through our RNA gel.